Let us look at the structure of phosphatidylserine. So the structure is CHOOCR2 and CH2OPOCH2. This is the serine which is attached here. So this is the structure of phosphatidylserine. How is it different from choline or from ethanolamine? It is only in the head group. So therefore, it becomes very easy to construct or synthesize this molecule from phosphatidylserine or from phosphatidylcholine. So let us see how we make phosphatidylserine from phosphatidylethanolamine. What has to be done is we need to replace the ethanolamine with the serine. So therefore, serine is added and ethanolamine is removed and you have phosphatidylserine. Name of the enzyme is phosphatidylserine synthetase number 1. Phosphatidylserine synthetase number 1 will convert phosphatidylethanolamine into phosphatidylserine. Can you make phosphatidylserine from phosphatidylcholine? It is very easy. So what you need to do is phosphatidylcholine, it can be converted to phosphatidylserine. You add a serine and what will be removed? Choline will be removed. And phosphatidylserine synthase enzyme number 1 that will convert phosphatidylcholine to phosphatidylserine. Simple way of making. What is important for us to understand is a cell will have different requirements of these phospholipids. So depending on the need, it will synthesize maybe more of phosphatidylethanolamine, sometime more of phosphatidylcholine, sometime more of phosphatidylserine, depending on the need. Suppose the need is to synthesize phosphatidylethanolamine. How do we convert phosphatidylserine to phosphatidylethanolamine? So it can be converted. How do we synthesize? So what we need to do is remove the CO2 group. Once the CO2 is removed, it automatically becomes phosphatidylethanolamine. What should be the name of the enzyme? That should be a decarboxylase. What decarboxylase? Phosphatidylserine decarboxylase enzyme can convert phosphatidylserine into phosphatidylethanolamine. Suppose if the need of the cell is to synthesize phosphatidylcholine, how do we synthesize? We add 3 S-adenosyl methionine and that will become 3 S-adenosyl homocysteine and you will get phosphatidylcholine. You see, depending on the need of the body, it will keep on synthesizing one molecule from the other molecule. So you get an overall picture about these many phospholipids. The next phospholipid which we are going to discuss is phosphatidylinositol. See, phosphatidylinositol is an acidic phospholipid. It's a very important phospholipid because you would have come across phosphatidylinositol in the context of inositol triphosphate acting as a second messenger, especially in the phosphoinositide cascade mechanism. It is the same phosphatidylinositol we are going to synthesize. What are the requirements for synthesizing phosphatidylinositol? So we require a phosphatidic acid, this is the first requirement, then we require a CTP molecule, then we require myoinositol. So these are the 3 requirements for synthesizing phosphatidylinositol. In simple 2 steps we will be making this. So therefore, what happens in this in the synthesis of phosphatidylinositol is step number 1, you have phosphatidic acid. So this phosphatidic acid will attack in the CTP molecule. So therefore, a CTP is added. It will attack the CTP, especially at the alpha anhydride phosphodiester bond, and once it attacks, PPI is liberated. What is left behind? Either CMP is left behind from CTP. That CMP is added to phosphatidic acid. So therefore, you will get CDP diacylglycerol. You will get CDP diacylglycerol. This is catalyzed by a transferase enzyme. Once you have CDP diacylglycerol, in the next step is to add myoinositol. See, inositol exists in about 9 stereoisomeric forms. Out of all these, only one, that is the myoinositol, which is optically inactive, that becomes part of phosphatidylinositol. So once myoinositol is added, so let us see what will be the structure of phosphatidylinositol. So the structure will be so if the myoinositol is going to be added here. So this is going to be the structure of phosphatidylinositol. So this is catalyzed by an enzyme known as myoinositol transferase. So you see how in very simple 2 steps, phosphatidylinositol is synthesized, which becomes a secondary messenger for in the phospholipid bilayer. Another important phospholipid is cardiolipin. So cardiolipin is another acidic phospholipid, and you will find cardiolipin abundant in the inner mitochondrial membrane. How is exactly cardiolipin synthesized? To understand the structure of to understand the synthesis of cardiolipin, we need to look at the structure of cardiolipin. So, in the structure of cardiolipin, pay attention to each of these molecules. So, tell me which is this molecule? This is nothing but glycerol. Okay, now to this glycerol, we are going to attach a phosphatidic acid. So, we will attach a phosphatidic acid here. This will be R2. One phosphatidic acid is attached. We can also attach another phosphatidic acid here. So this will be so therefore you see that one phosphatidic acid here, another phosphatidic acid attached to a glycerol unit. So therefore this is the structure of cardiolipin. You can also say that this is diphosphatidylglycerol. Another name, name for cardiolipin is diphosphatidylglycerol. Let us see how we synthesize this particular molecule. In the starting of synthesizing this molecule is, we will begin with glycerol 3-phosphate, and CDP diacylglycerol. So these are the starting materials for synthesizing cardiolipin. In the step number 1, CDP diacylglycerol joins with the glycerol 3-phosphate, and to glycerol 3-phosphate, one of the phosphatidic acid is added. So therefore, and the CMP molecule is removed. Okay, once you remove CMP from this to the diacylglycerol get phosphorylated, that becomes phosphatidic acid, and that is added to glycerol 3-phosphate. You will get phosphatidyl glycerol 3-phosphate. You will get phosphatidyl glycerol 3-phosphate. If the enzyme is a transferase enzyme, let us write the structure of phosphatidyl glycerol 3-phosphate. So therefore, glycerol 3-phosphate is this. This is glycerol 3-phosphate. Phosphatidic acid is attached to this. So therefore, here phosphatidic acid is attached. This is the structure of glycerol 3-phosphatidyl glycerol 3-phosphate. So once this structure is formed, now we want to attach one more phosphatidic acid to this. But you see that there is already a phosphate group there. So the next step is to remove that phosphate group. How do we remove the phosphate group? We will use an enzyme known as phosphatase. So phosphatase will require a molecule of water and inorganic phosphate is removed. Once the phosphate is removed, what will you get? You will get phosphatidyl glycerol. So once you have phosphatidyl glycerol, can you add another phosphatidic acid? Yes, you can add. How do you do that? So therefore, this is converted to phosphatidyl glycerol provided you add one more CDP diacylglycerol. When you add a CDP diacylglycerol, what will be removed? CMP molecule is removed. And you need another enzyme, that is the same enzyme that catalyzed here, that is a transferase. We will need a transferase enzyme here in order to catalyze the phosphatidyl glycerol into diphosphatidylglycerol glycerol. So this is the structure of cardiolipin, which is abundantly present in the inner mitochondrial membrane.